because we cryogenically cool the liquid oxygen down to about negative 340 degrees Fahrenheit, and then we load it onto the stage so it's as dense as possible so we can get as much propellant onto the stages and give ourselves as much margin for the mission. Coming up at this moment, it's about T-minus 8 minutes. We did check out our spacecraft, Koreasat. They transitioned to internal power about T-minus 20 minutes. They've given for today's mission, tracking no issues. We are also launching from Kennedy Space Center. So we are working with Kennedy Space Center team as well as the Cape Canaveral Air Force Station. They have cleared the area and secured it around Launchpad 39A. They've also cleared the corridor leading out of the pad downrange and given us a go for today's mission. Looking at the weather, it's a beautiful, beautiful, beautiful blue sky, 65 degrees and sunny at Cape Canaveral, tracking no issues at the moment for weather. So with all stations indicating go for launch, let's take a little closer look at today's payload. Koreasat 5A is a communications satellite operated by KT-SAT. That's South Korea's sole satellite service provider. The satellite was manufactured by Thales Alenia Space and located at 113 degrees east longitude. Koreasat 5A will provide direct-to-home broadcast, broadband, and backhaul services with its KU band capacity. Koreasat 5A provides KT-SAT with 12 KU band transponders of 36 MHz and 24 KU band transponders of 54 MHz. Now, as a replacement for Koreasat 5, Koreasat 5A will expand upon its coverage across Asia and the Middle East. And unlike other satellites in the Koreasat fleet, Koreasat 5A will provide maritime coverage of the Persian Gulf, Indian Ocean, South China Sea, and East China Sea. Koreasat 5A is also equipped with 4 extended KU band steerable transponders of 54 MHz each. These steerable transponders will provide commercial direct-to-home broadcasting services in the North Asia region by the end of this year. The Koreasat 5A satellite arrived at SpaceX facilities in early October and has been undergoing preparations for its launch today. It weighs about 3,700 kilograms at launch and offers payload power of approximately 6.5 kilowatts. You're seeing that satellite getting loaded into its shipping fixture on the screen right now. That was brought into an airplane, shipped to Cape Canaveral, and arrived at the SpaceX facilities just in that transport crate you see right there. Now, Thales Alenia Space is the prime contractor for Koreasat 5A in charge of its design, production, and testing, as well as the ground delivery. The company is also responsible for its launch campaign, the launch and early operations phase, and in-orbit testing of Koreasat 5A. Now today we are taking Koreasat 5A to a geostationary transfer orbit. And on your screen we have a quick animation. You can see the launch with first stage landing. That second stage has its first burn. After that burn we have a fairing separation during it. We will coast for about 20 minutes. Then we're going to have a second stage, second burn, about T plus 35 minutes and 30 seconds. We're going to have our payload deploy. Then Koreasat 5A will use its own onboard thrusters, put it in a final geostationary orbit at about 36,000 kilometers away from Earth. You can see it's matching Earth's rotation. That's how it actually covers a singular spot of Earth's sky, and in this region instance, that 113 degrees east longitude position. So we're about T-minus 4 minutes and 20 seconds in today's mission. As of right now, we're finishing up that LOX load on the first stage. No issues to report right now. The forward arms of the strongback have begun opening up. Everything there is looking good to report. It will fully recline at liftoff. At T-minus 7 minutes, we began the engine chill process of our first stages. That's where we actually are flowing in that liquid oxygen into the first stage engines. That kind of chills down all of the metal components of the Merlin engines, and so that way they don't actually flash into gaseous oxygen at liftoff. It protects the engines and gets it ready for the actual ignition points. Coming up at the T-minus 1 minute mark, Falcon 9 is going to enter into startup. That's actually the moment where our ground computers are going to hand over the countdown process to Falcon 9. The onboard flight computer of Falcon 9 will take over the countdown at that point. It'll do its final checkouts of all the sensors, which will lead us up into liftoff at T-0 mark. So, recapping where we're at right now, our payload is on an internal power, giving us go for today's launch. Our fairing boat is, our drone ship is out in the sea, 340 nautical miles, go for today's launch. Our rocket, Falcon 9, go for today's launch, topping off liquid oxygen right now. Weather's looking good, range is good. So at about T-3 minutes, let's listen into these final few minutes of the countdown process.
Stage 1 LOX is closed out for flight.
MVAC countdown 1, confirm TVC is nominal.
Stage 2 TVC motion's nominal.
Stillings will give the launch countdown.
Stage 2 LOX is closed out for flight. Vehicles in self-line.
Gas closeouts are started.
AFTS is ready for launch.
Falcon 9 is in startup.
Gas closeouts complete.
Stage 2 pressing for flight.
LD on countdown 1, we're go for launch.
T-minus 30 seconds.
Stage 1 pressing for flight.
T-minus 15 seconds. Stand by for terminal count. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Vehicle pitching downrange.
Stage 1 propulsion is nominal.
Power telemetry nominal.
T plus 50 seconds in today's mission. We are on our way to delivering Koreasat 5A to a geostationary transfer orbit. Watching the 9 Merlin engines of the Falcon 9 first stage.
Falcon 9 is supersonic.
Capable of putting out over 1.7 million pounds of thrust. About 5 seconds ago, we transitioned to the supersonic regime. Coming up in about a second, we're going to hit
Vehicle
max Q.
experiencing maximum dynamic pressure.
We actually just passed through max Q. That's one of the highest stress states on the vehicle. propulsion avionics continues to look nominal.
MVAC engine chill has begun.
You heard the call out. The Merlin vacuum engine of our second stage has begun chilling in. Same process as the first stage, where we start to flow that liquid oxygen through that second stage engine. This first stage burn will last for about another 30
Recovery bird
seconds.
has AOS.
In about 10 seconds, we'll have main engine cutoff. All 9 Merlin engines at that first stage will shut down. About 3 seconds after that, we will see stage separation, where the first and second stages will be separated by 4 pneumatic actuators, and then we will have the ignition of our second stage engine. Let's watch.
Miko.
Stage separation confirmed.
And we have a good ignition of the Merlin vacuum engine of our second stage. You can see the exhaust plumes coming from the forward view of our first stage on the left screen camera. Our grid fins have also deployed, as you can see there. We use those grid fins to guide ourselves back through Earth's atmosphere to our drone ship, Of Course I Still Love You. In about 15 seconds, we'll have separation of the fairing from our second stage. That's a view inside the fairing. Koreasat 5A on the right side. And we have separation of the fairing. It's a good separation.
Second stage is following a normal trajectory.
And we have a call out that second stage is following a nominal trajectory right now. Everything looking good. Meanwhile, first stage is continuing to guide itself down. We're coming up on entry burn at about the 6 minutes and 23 seconds for the entry burn. Now, in addition to using those grid fins for guiding ourselves back to the ship, we do have cold nitrogen thrusters. That's those white puffs of smoke you see coming on the screen on the first stage image. We also use that to help orient the stage back to the drone ship. Our second stage burn is going to last till about T plus 8 minutes and 30 seconds. Then that second stage engine will shut down. We'll be coasting for about 20 minutes. And then we will have our second burn to put Koreasat 5A into the final geostationary transfer orbit. Entry burn coming up in about a minute for the stage one. It passed through its apogee of about 110 kilometers. So now we are accelerating back to Earth. We use that entry burn to negate a lot of the vertical velocity that the rocket is built up and help slow down the entry speeds. So a more gentler touchdown. Entry burn will be about a 20-second entry burn. We're using a combination of 1 and 3 engines, depending on different timing and sequences of this burn. Today, there is only 2 burns since we are landing on the drone ship. We're not going back to Cape Canaveral. So we just have the entry burn, followed by the landing burn at about 8 minutes and 6 seconds.
Drone ship AOS.
Stage 1, AFT.
20-second burn.
Stage 2 continues to follow a normal trajectory.
Expected loss of signal Cape Canaveral.
We'll have our landing burn in just about a minute of stage 1. Single engine landing burn. Now we may lose signal, as you saw there briefly with stage 1. We are getting the feed from a satellite in the drone ship. Choppier seas, which makes our satellite link a little bit more challenging, but we will provide you guys updates as we have them. Meanwhile, you're looking at a live view of stage
1
2.
is transonic.
The call out for stage 1. Passing through transonic regime just came. Trajectory continues to look good for this second burn, or first burn of the second stage, which will have cutoff at about 8 minutes and 30 seconds.
Stage 1 landing burn has started.
The landing burn for stage 1 has begun. A 30-second landing burn.
Stage 2, AFTS.
It's a live view from, of course, I Still Love You, our drone ship out in the Atlantic Ocean.
And we have signal.
We do have confirmation while we're waiting for an image from the drone ship that we did have our second stage engine cutoff. But if you've tuned into past and webcasts, you've noticed that we have lost feeds in the past of our stage 1. Right now, we don't exactly know the state